Hey, my name's Freya, and in this video I'm going to teach you the easiest way to get from knowing no code to a working AI CNN through your dataset. So I know nothing about code in the grand schemes of people on YouTube and coding, but after hours of watching videos, this is what I've found is the easiest method to get it working. I've got a Google Colab document in the description that we'll work through together, and then if you want to learn more about how to code specifically, I'll link other people's videos that have helped me in the description. But without further ado, this will be the shortest video on how to go from zero to a working CNN. Let's go. Okay, so we know what a CNN is and we know what YOLO is, but what does it actually do? So what's going on behind the code? I have got an article on this if you want to go more in depth, but it's essentially takes an image, and if you imagine you have a little window, and when you put that on the image, that's all you can see. So that window will then go, okay, is there the object I want to identify within that part of the image? And it does that using weights, which is essentially, it can be, there'll be numbers, so -1, 0 or 1. And the way these weights are in the filter or matrix will bring out different features. So if you've got a line of -1, line of 0 and line of 1, it will be looking for straight lines, the same if they're horizontal. And these get a lot more complex, and it actually learns from these weights and adjusts them at the end of every convolution. So that means if you do more repetitions, or epochs as it's called, so where the code goes all the way through all the images again, it will be adjusting these weights and then identifying the images, the objects in the image better. And then by taking the outputs of these weights and using matrix multiplication, it will enhance features of the image and then that leads to the box drawn around the object and the name of what it thinks it is after it's gone through all these filters. So if that made any sense, I'm hoping that made some sense. You can read the article on it where I talk about value layers and back propagation, but we're going to dive into the code. So if you go on to the Google Colab document that's in the description, you'll be brought to this. And then you literally click File and save a copy in Drive. So it will create a copy for you. Awesome. And then we're going to get to it. So the first step is literally, as it says, is making sure you're using your graphics processing unit if you have one. If you don't, it's not a big deal, it'll just take longer. So when this code runs, it's just connecting to everything. And then that says that it's using the GPU. If yours isn't, you can go up here in runtime and click change runtime and then select GPU and save. Okay, so that's just getting it started. You can obviously change the name of it to identify what you want. The next part, go into Google and type in Roboflow. Click on that and then sign in. So if you don't have an account, you'll obviously have to register and sign in, but if you do, then just sign in. And then I've got this one, so you can find this, I'll put it in the description as well, but you can find this tree counting one that I've made and copy exactly what I'm doing, or you can upload your own. What you do is you'll upload images and then you'll annotate them, and annotating, I'll show you some of them here. So to annotate, you will have, you literally draw a box around what you want to annotate and then save, and then just do that. You can share this, so you can share the workload, because I annotated 1072 images, and a bit random number, but you can share it. So if you're going to do a huge data set of about 3,000, I'd recommend asking a friend to annotate some for you. It's not very, it's a bit of a mind-numbing job, but you have to get it done. So after you've done all that, annotate, you can generate. And I've done previous models of this, but we're going to go ahead and click create new version. And then we've got our source image, they're all annotated. These are the training tests, but you can't edit this. So that says 80% training set, validation set, and testing set. That's fine. You roughly do 80, 10, 10, or you can change it, but it's good to have enough to validate on. So I stick with 80, 10, 10. Processing, so these are really good because it increases your data set. So auto orient is if the images are at different orientations, then it's different. If you're doing something like cars on the road, this wouldn't make sense because you're not going to be identifying cars that are on the road and the roads above them. But this worked for me. And then resizing to different sizes. You can also do cropped, tiled, grayscale. There are options there. Just make sure they make sense for the data set you're using. I'm going to stick with those two. Rotation, similar to above, you can add another rotation, but I'm going to stick with just 90 and 15 plus 15. There you go. So now you can obviously upgrade if you want, but I'm not paying for this. So my data set of 1072 is now 2780, just through adding those different variations of images. I'm going to click there and it will generate for you. Now it's generated all the versions. We're going to hop back over to the code, but we'll leave this tab open so we can come back to it later. So going back to the code, this section of code, you don't actually need it too much. You'll need to import the OS, but it's mostly just housekeeping, so make sure everything's in the right place and kind of organized. Okay, so this bit, if you don't want to type it out yourself, you can literally just hit play. You will have to add some code in, but that's really easy to get. But this is really easy. So this is installing Ultra Analytics, which I've written what it all does out like here. So literally every line of code and then what that line of code does. So this is just importing it, so it'll be able to display an image and read images, because without that, then it'd be pretty useless. Okay, awesome. So this is the bit you need to change this step here, step 4. So go back onto Roboflow, you can click get snippet. I'm using YOLOv8 just because it's the newest one out. A lot of people use YOLOv8. Okay, so this bit's really important. You can show snippet, so it will be going, and it will come up with the snippet of the files like this. So when I copy this, that blacked out bit will go, but as it says, like, don't share this, because you can use it to get into other people's accounts. So just going to copy that. Don't actually need that bit of code there. And then I'll paste this in, but I'm going to black it out again on the video. But where that API key is, where the blacked out bit is the code that I'm using. So we're going to run that. And it it's gonna take it from Roboflow. So this is the whole data set it's downloading, so all the images and all the labels. Okay, so after you've done that, it came up with a warning last time. That's gone now, so I had to restart my video. But if it wants you to restart your runtime, just restart it and then scroll up and then just start from the top. Make sure you're using GPU as well, but just start from the top and just click play on all of these, and then it should sort itself out. Awesome. So this next bit is the bit that it does take a while. So it's detecting and it's training. This is what this means. The epochs, like I said earlier, is how many times it runs through all the images. So it's running through 15 times on 1,000, how many was it? Like 2,000 something images. So it will take a while. This is your image size, if you know it. If you don't, it doesn't matter. So this, I'm going to do 15 because I know that's how many works. If you've got a smaller data set, I'd recommend you do more, but the more you do, the longer it takes. So this usually takes about half an hour. So I'm just going to click play. It will download everything for me. Awesome. Now it's done all of these epochs. I'm going to quickly talk through. So when it says GPU mem, that literally means how much of the GPU is the YOLOv8 CNN using to classify all the images. Box loss means, so with the bounding box, which is the box around the image, the object in the image you're trying to classify. So it's how accurate it's doing that, how much it's losing compared to the pre-labeled ones. Class loss is how accurate is it classifying them. For my data set, I'm only classifying one thing, so I'm not identifying bikes and cars in the same image. I'm literally only identifying trees, so that one doesn't really matter for me. DFL loss stands for detection fidelity loss, and that is how accurate it is at detecting small objects. So for me, on my last epoch, it gave me 0.9, so that's 90%, which is pretty good. And then instances, it was 0.94, so 94% detection rate. That's pretty good for just 15 epochs. I mean, ideally, you'd train it for a lot longer. So I'd probably, if I was going to do it again, I'd probably go up to maybe, 50 epochs and see what a difference that makes. Okay, so that one that just runs detect, that's just sorting it all out in the files, which I'll show you in a minute. And this should show you the confusion matrix. This will be different for everyone. Mine is very simple. What a confusion matrix does is it shows you what it's identifying as what and where it's got confused. So where it's identified maybe the background as a tree or the tree as a background. So this is fairly simple. When you've got a lot more variables, so let's say you're doing a football match and you're detecting the ball, the player, the ref, the goal, then you'll have a lot more things in there and it will look much more complex, but it's really good to show you where it's getting confused. The next one, this shows you the results of the training. So like I just went through with the numbers, but as a graph, which is quite cool. So the box loss, you can see that drop down drastically. Train loss again. Some of these metrics, this just showing how accurate it is, and actually you kind of want them to taper off into a bit of a curve, and they obviously haven't got there, they're still super spiky on mine. So I should probably train it for a bit longer to get more accurate results, but what can you do? Okay, so this should show an example of your code working. There you go. So there's an image, or like multiple from the validation set. So it's detecting different trees. You can see in some of them it's got one, but maybe not the others. If you want to see, so that's pretty cool. It's like a little preview. When you upload it back to Roboflow, it will show you a lot more of so you can upload an image it's never seen before, and it will use your training that you've coded and show you that, see how accurate you've got your coding and your model. So let's just run through this. Just make sure everything's working. These sections, like I did say, so this is just organizing the files and showing images. So that's organizing all the files. If you want to see your files in here, you can click Files, Dataset, Tree Counting, and then you can validate images, and then you've got all the images here. You can literally click on one, and that's the images it's using to do your like train your model. Let's click on train images. Don't know why there aren't any in there. Weird. Test images. I'll click on one here. I don't know why this isn't working. Okay. So this is So this is where all your files are. So that's what this is doing. It's just organizing everything and all your files here, so you can see what it's training on. But that's not necessary when you're using Roboflow, because if you click this one, project version deploying, so when this is done, it literally deploys it to the Roboflow universe. So you can go back on here, you click the link that it produces, sign you in, and what this has done is, so you've taken images that you've annotated on Roboflow, you've trained them on your Google Colab, and then it will update the trained model, and then you can upload another image and it will show you, you can see how well it detects it. Pretty cool. Now that's uploaded, there you go. You can see the recalls 89.3, precision's pretty good, it could be a lot better. And then you can play around here, so if you put the confidence down, it finds trees. Obviously you don't want to go too low, otherwise it finds trees that just aren't even there. And then you can try with other images. There you go. I will say I should have probably trained this a bit better, maybe more than 15 times. But you can play around, I can train it again. So there you go, enjoy. And as I promised from the start of this video, I'd show you the easiest way to get it working. So this way is literally using no code. You can generate a new version, and instead of getting the snippet and putting it into the code to train it, you can literally click start training. Unfortunately, I can't show you this because I've already tried it out and you only get 1 credit on the free version, but it's pretty simple. Just start training it and it will train it itself. I think this one, I did the automated Roboflow training and the results were better than I got on my code. This isn't because it is better than code, it's just because it's gone through more epochs, so it went through, 93 or something? And so it got better data. So if I went back to my code and did 100 epochs, I would get similar results to this. And then you can just try the model of these images. It'll put it up. And then if I drop the confidence, there you go, it's found all of the 5 trees there. Pretty simple. So if you really didn't want to code, it doesn't get any easier than that. So there you go, have fun. Hopefully it makes sense. Please read and understand the code if you're doing the code. If you just want the results, there you go, use Roboflow and enjoy. Okay, that is it. I hope you enjoyed the video. I hope it was helpful, you understand a bit more, and most of all, I hope you got it all working. If you didn't, you can ask questions below or use the links I put in below for some help. But yeah, good luck and let's do this.